Today we have Muneeb Ali, co-founder of one of my favorite crypto projects, Blockstack. I'm a big fan of this project ever since I heard Muneeb talk on TEDx way back in 2016. Welcome, Muneeb. It is a pleasure to have you on the show.
Well, excited to be here.
Muneeb, I just recently saw the news that, Blockstack's cryptocurrency, native cryptocurrency is now going to be freely tradable on UX exchanges. Exciting times.
It's been a kind of like a long journey for us, especially given the SAX 2.0 launch and the careful approach we took with regulations here in the US. So we did the SEC qualified public offering, and then we've been treating the Stacks cryptocurrency as if it's a security in the US so far. And we've been doing the reporting and SEC filings that are needed. And that's like a very kind of like on the spectrum of things, it's a very careful approach. And now with the Stacks 2.0 launch, we released the legal framework through which the treatment of the asset can be a non-security in a very kind of like clear way. And we're super excited about releasing that.
That's great. So this is a good segue to my list of questions that I have for you. So could you talk a little bit about your journey so far with Blockstack and crypto space in general?
Yep, happy to. So in general, like my background is in computer science. I did a PhD in distributed systems from Princeton University. And I've mostly, like throughout my life, I've mostly been doing research work in internet protocols or large scale distributed systems. And the way I discovered crypto was actually through the same kind of like channel, right? Like I was working on kind of like next generation internet infrastructure, that how do you build a more secure, better internet, right? I know it's a very kind of like ambitious thing, but it happens a lot in the distributed systems research community, where I think the one difference that we had was like we were not interested in building just a prototype or just writing research papers about these clean slate internet architectures, but actually wanted to commercialize it, right? So pursued it as a startup instead of a research grant at a university, and I think that made all the difference, right? Because we are working on real world challenges and commercialization of the research, and not just theoretical work that just stays in a research lab. So with that, we ended up kind of like discovering blockchains and crypto. This is back in 2013. I think Bitcoin was like $90 back then, and the crypto community was much, much smaller. Obviously, the industry has grown a lot since then, but I think it's still fairly early days and still very small. And we discovered crypto and blockchains almost as an elegant solution to some of the problems that we were trying to solve for having a better internet, for having a more user-controlled internet, and fixing some of the fundamental design challenges for the internet. And where this has evolved over the years is that within that broader kind of like mission, we've actually developed a thesis around Bitcoin. Like it's almost like, if you go to the early days of the internet, at one point there were actually these protocol wars, right? Like it wasn't clear which technology or which protocol stack is actually going to end up winning. And people were pushing all these different architectures and designs, and networks, started getting built on top of TCP/IP. And I think we're going through that phase in crypto a little bit, where there's Bitcoin, there are blockchains like Ethereum that enable smart contracts, and then there is almost like a half a dozen other protocols that are trying to address some of the challenges with Ethereum's approaches and so on. And we're in the camp that we actually think that most of the innovation is going to happen on top of Bitcoin. And it's a very contrarian approach if you look at the market right now, because most people are treating Bitcoin as a almost like a digital gold, pretty much like a one-trick pony, right? And you hear that phrase, that Bitcoin is a one-trick pony. It doesn't do anything else, and it's not going to change, and it's just going to be digital gold or sovereign money. And we couldn't disagree more in the sense that TCP/IP never changed, right? It became a standard, and people could just build on top of it, innovate on top of it, and TCP/IP did not need to change for that. And I think the same thing is going to happen with Bitcoin, and it's already happening. This is the core thesis and the design that we have, where we are kind of like building those missing features and capabilities that are not in Bitcoin, but more importantly, they should not be at Bitcoin. It's actually the correct design decision to not have smart contracts at the Bitcoin base layer, to not try to basically have the kind of scalability at the base Bitcoin layer, because you're trying to solve different challenges there, right? Like once you solve those challenges, you have the base layer that can then support these side chains or connected chains, like in our case with stacks, and you can actually use the base layer as a settlement protocol, right? So the power of Bitcoin as a value settlement protocol is barely explored at this point, right? And the work that we do, like, building a better internet, we actually think that the foundation for that is Bitcoin, right? And today, if you look around, this is the contrarian approach. This is not a very well understood thesis, but we think that especially with the launch of Stacks 2.0, when people see this working and in action, I think people start realizing that, oh, this is actually a much better design and a more scalable, more kind of like suitable design, especially given the network effects of Bitcoin.
That's a very valid point. So you're kind of giving superpowers to Bitcoin, in terms of having all these applications built on top of that. I wanted to piggyback on that and ask you. So you had mentioned in your initial talks also, this was that Blockstack is based on like an end-to-end design principle from the chief protocol architect of the internet, David Clark. And so, I when I heard about it, I read his book, and then a lot of things made sense. Could you elaborate a little bit more on how Blockstack is built on those principles? I'm not against the other projects who have a different approach, like Ethereum, Ava, and all other, projects out there. Like, how is it fundamentally able to scale from day one and do all those sorts of things it does?
Yep, happy to go over this. So I think it's first, let me give a little bit background on the end-to-end design principle. It's a pretty simple design principle at a high level. Basically, what it says is that when designing, complicated systems or computer networks, you should try to keep the core of the network, the base of the network, as simple as possible, and push the complexity to the edges, right? And the internet was designed that way, in the sense that if you look at the core IP protocol, it has no idea about what data it's even delivering. It is actually a fairly dumb protocol. Like, it takes data from point A to point B. Doesn't even give you guarantees on delivery of that data. It's a best effort kind of a system, and that's about it. Right? Like, there's nothing else. And a lot of other designs were actually trying to build intelligence in the middle of the network. And end-to-end design principle, TCP/IP, ended up winning by a lot, right? So that simplicity of the core of the network, it's a little bit of a high-level design principle that allows you to then almost like avoid a lot of the traps down the road if you go down the path of like trying to make the middle of the network or the core of the network more complex. And interestingly, Bitcoin actually fits that, right? Like Bitcoin, just like for IP protocol, it was a little bit like it only does one thing, and a very simple thing. It transmits data from point A to point B, and that's it. If you look at Bitcoin from that lens, in some ways, it does one thing, and a very simple thing. It basically says that here is a transaction that transfers some amount of value from one address to another address, and that's it. Nothing else can be done. But then people can actually start using kind of like these simple abstractions to build more complicated things on top, which is exactly what we are doing, which is exactly what happened with the internet as well. But the other place where this plays out is we want the applications to have most of the logic. If you if you look at some of the apps built on top of the Stacks blockchain, you would notice that you're downloading the app and most of the logic is actually local, like on your laptop or on your machine, right? And there isn't a lot of global state, meaning that if I download a Pravica and you download Pravica and we start chatting on Pravica, we're not actually changing any global state other than my username that I registered once or your username that you registered once. Whereas if you look at the other architecture, the inverse of that, where all these apps are literally running on some sort of a core of the network, every single interaction is a transaction. Like everyone, when more people start using the system, the core network needs to scale. I think another way to understand this is the analogy would be that a network like Ethereum is actually something like a mainframe computer, right? So the more users you get, the mainframe actually needs to be able to support like that kind of load and scalability, and one user can actually slow down other users. Whereas if you look at the internet and how it's almost like most of the users and the complexity is at the edges. If I'm trying to chat with you, I'm not slowing down some random chat that is happening between two other users, right? Like it's a more of a complexity at the edges type of a design. And we bring that design to the Stacks blockchain. Obviously, there are smart contracts that can only run at the blockchain level, but most of our apps and the logic of the apps, or even the storage system, is kept with the users and the end devices as much as possible.
Right. And I like the fact that you're also blockchain light. What I gathered is not everything has to be on the blockchain. Traditional developers in the space, especially in India, there are a lot of Java developers, front-end developers, some of my colleagues and myself including, who are going through this learning process to say make the switch to Blockstack platform and build applications which are privacy protecting, which also have other features like aspect of the application can be on a blockchain, and then have encrypted storage.
I think the main thing to understand for developers who are looking at this space is that most of the blockchain inner functionality and details will most likely just be hidden from developers, and that's a good thing, right? Like you don't have to worry about how Bitcoin achieves consensus or how consensus works on the Stacks chain, between the Stacks chain and the Bitcoin chain, and so on. And there's going to be tooling. There already is, right? So the Stacks blockchain has a Stacks blockchain API, which is far more simple. Even the code base of people, it's open source. People can check it out on github.com/Blockstack. And they're mostly looking at the API, right? Like how are they going to interface with some of the functionality? And I would broadly categorize divide things into two. There are two different tracks. One is smart contracts. The smart contracts are the subset of logic that actually should run at the blockchain level. And over there, the way to think about this is what are the things that actually need global state and they need to execute at the blockchain level. Let's say that you're writing some logic where you want some automatic trigger that if X is true, send this transaction, and you want this to be completely trustless. You would publish that as a smart contract on the blockchain. And over there, like the model should be that people should view blockchains as like extremely limited in bandwidth and computation power. So whatever you're trying to publish there, you better have a really good reason for why this functionality should be implemented as a smart contract, right? And I think it's very different from the kind of marketing we've seen from some of the projects in the past, where they try to position a blockchain as a world computer. And then you get these JavaScript developers who almost literally treat it as a computer, right? Like just write any program you want and publish it at the blockchain. Like that doesn't scale. And it's a wrong mental model, right? So we should almost like treat blockchains as I think they're extremely valuable because you're not trusting anyone with the code that is executing on the blockchain. But only a subset of logic makes sense to be written as a smart contract and published as a smart contract, right? The rest of the logic, and that's the applications. This is the software stack that is off chain, right? That might be, authentication systems, more scalable storage systems. Again, blockchain is not a store of data. It's not a database where you can just start dumping large amounts of data. You can actually have pointers to that data, and that the data stores are outside. And most of the over there, like at least in our developer tooling, we try to make things as familiar to existing Web2 tooling as possible. So instead of using, some login library from Facebook, you can actually use the Stacks login library, and it gives developers a way to do authentication in a decentralized way, and same for storage and so on, right? So broadly speaking, I would say that if you're a new developer, you basically need to figure out like the smart contract language aspect. And for us, like that would be Clarity. Like it's a new language. And the reason why we have a new language there is we really want to optimize for security. We want to give developers really precise tools so that they don't end up hurting themselves when they're writing smart contracts, and they can actually have formal proofs of execution. They can figure out, what their program is going to do once it's in production on the blockchain, even before kind of like executing it. So there's a little bit of a learning curve there, right? You would learn the smart contract language, you would learn how to publish these computer programs at the blockchain, and so on. And then the second track is where you learn about the rest of the stack. That what are the other components that kind of like coordinate with the blockchain and interact with it in the background, and they are all decentralized in their own ways, but they're different kind of like plug and play type stack components that are needed for building a full application. Like imagine, it's entirely possible to build a Facebook-like application or a LinkedIn or, other types of things that we haven't even thought about, where, you can integrate smart contract functionality, but you can have the rest of the user experience as a decentralized application as well. So for that, you're combining the two tracks, right? That you figure out what should be a smart contract. Like I'm just making something up just for illustrating this. Let's say that you have created, some sort of a crypto index fund, right? Where there's a smart contract that can actually, take a position in top 10 crypto assets, and people can actually back it with real money and so on. You could build a decentralized application, with a login, with storage, with the profile and all the UX and everything as a Web3 application using the tooling that I mentioned, and have a deep integration with the Clarity smart contract. But that Clarity smart contract, like you can imagine, the security on that contract is 100x more important than other things, because it's almost like a fund. It is managing users' funds on their behalf. It's actually kind of like taking a position for these, top 10 assets that you programmed that it's trying to purchase or sell or so on, right? So that would be a combination where the decentralized app has all the UX and the profiles and the kind of like look and feel of Web2 applications. None of that is needed at the blockchain layer, but the actual smart contract that is managing the funds would be deployed as a smart contract at the blockchain layer.
I was going through some portion of it. So it's basically Lisp based, I believe, and it's more functional. And the whole industry, traditional web, is also moving towards more functional sort of hybrid languages.
Yep. So I think the way to think about this is the way the crypto industry has evolved is effectively back in 2015 or so, Ethereum came out with kind of like the first real smart contract language on a blockchain. And there were certain design decisions that they made, which I am very critical of, and I've been very publicly critical of those design decisions over the years. And I think those design decisions have actually led the industry in a certain direction. And the decisions made on the smart contract programming language is one of them, right? So they effectively took JavaScript and cloned it, made some modifications, and are using that as a smart contract language. And I would think like it's very hard to actually find like a worse language to do that in, right? And I can understand the reasons. I think the reasoning would be that JavaScript is a widely used language. A lot of developers already know it, so they would be familiar with picking up Solidity because it would feel like JavaScript to them. I understand that. But that is not what we're trying to optimize for here. Because what we're trying to optimize for is actually these smart contracts are a completely new type of a computer program that are meant to keep hundreds of millions of dollars literally on the contract itself, right? So this is very different from, building websites in JavaScript. And even if the website crashes, who cares? You can just restart it. This is more like almost like programming an airplane, and that airplane cannot crash because people's lives are at stake there. Similarly, the amount of mission critical code that gets deployed as smart contracts actually just calls for a very different type of a design over there. And that's kind of like what we did with Clarity. Like there were certain design principles that we were following, and avoiding a Turing complete language is one of them. So you wanted things to be very precise. You wanted to know exactly what is going to happen, not that you actually cannot predict what the Solidity contracts are going to do until you execute them, right? And then there are all sorts of problems like reentrancy, and there's an entire list of it. I'm not going to go into that.
Right.
But they're all downstream of this decision. Like imagine that decision was made like 5 years ago, and I'm not sure how much of a technical debate there was to evaluate these different schools of thought, right? And now an entire industry is kind of like feeling the impact of that design decision, right? Because most of the smart contracts these days, even other projects, they try to make themselves compatible with the EVM, right? Instead of kind of like saying that, hey, here's a better path, here's a different path, let's do that. Because I think like our industry is still early enough that you would need to correct some of these earlier decisions and have much better tooling in place to help mature the industry, right? And so over there with Clarity, like the language itself was designed ground up to maintain certain properties like, that you can actually have formal proofs of execution. Properties like you can have these post conditions around contracts that no matter what the contract was doing, if these conditions are not true, abort, like don't do anything else, right? Or even imagine that we went to the extent of even avoiding compilers. Sometimes compilers can actually introduce unintentional bugs in programs, and with smart contracts, like there's this concept of like code is law. Well, code is law, but which code? The code that the developer wrote, or the code that the compiler is spitting out, right? Because it's the compiled version that is actually published on the blockchain, and that version might actually do something that the programmer did not intend to do. And compiler bugs are a real thing, right? Like even with really widely used programming languages like Java, you would actually see compiler bugs getting discovered, right? And we are talking about smart contracts here again that are holding like hundreds of millions of dollars on them, a situation that no computer program was in ever before, right? So every design decision that we took, we were trying to optimize for this unique environment of smart contracts. And we're very, very happy with where we landed. I think it's a very powerful language. Yes, it's more on the syntax is more like a functional language, like it would remind people of Lisp, but it's a new language, and people can pretty quickly get a hang of it. Like we are actually seeing in different hackathons and kind of like developer activity, people were very quickly able to build most of the highly used smart contracts in the industry right now, right? So it's fairly, relatively straightforward to do that, and that's very encouraging. That our language, because it's a little different and there's a learning curve there, is likely not turning out to be a limitation. People are able to very quickly write similar types of smart contracts. Obviously, these are much more secure in clarity compared to what exists out there in the industry right now.
You're not alone in the constructive sort of criticism. I follow Bram Cohen, just for the audience. He's the founder of BitTorrent, like the original creator of BitTorrent. So I saw a talk between you and him a long time ago, which he's openly discussed these issues also. So, I mean, that's, I feel like the whole community gets too angry on like if, proof of work versus proof of stake debate, and they get it should be more healthy discussion around that.
Yep, and I think a lot of other people are coming to the same conclusions as well. Algorand, who was started by Silvio Micali, who's a Turing Award winner professor at MIT, really considered as a godfather of applied cryptography and theoretical computer science. They pretty much have the same approach to smart contracts on the Algorand chain. They, in fact, even ended up collaborating with us on the Clarity language itself, and they're looking into porting the Clarity language to Algorand as well, and a bunch of other newer projects. Like I would say that at this point, if you talk to kind of like sophisticated researchers, you would actually find that there are more people who are in our camp versus people who are trying to push Turing complete languages or for that matter JavaScript like languages. Just like when I was talking about developers, that there are really two tracks, the smart contracts and then the decentralized applications, I would divide use cases into those two categories as well, but the lens would be a little bit different. I think the lens would be on the smart contract side, you're effectively looking at decentralized finance, right? So it's like trying to disrupt Wall Street, like you're trying to create lending applications, like decentralized exchanges or other types of new financial products that weren't possible before, and that's all very exciting. And if anything, the last 6-7 months have actually shown that some of these DeFi products are actually finding product market fit very rapidly, and you can see why, right? Like imagine that developers never had this superpower before where they can like plug and play, take different APIs and smart contracts, remix them, and just publish a new type of a financial product, and then capital starts flowing into it, like without going through any banks or any processes or any central authorities and so on. So I think it's very, very exciting. It's kind of like cracking open this black box, which is the financial institutions, and engineers can basically start taking, piece by piece, like dismantling some of those services and building them in very open, transparent ways, and then connecting them together in more open, transparent ways, which is very, very exciting. But it's in the camp of like, almost like disrupting Wall Street, or, like bringing the next generation financial markets online. Maybe even Wall Street will end up joining it at some point. Like who knows, right? But the other track is more around decentralized applications, and these are we've seen the growing concern with antitrust efforts against Facebook and other large tech companies, like how much tracking and surveillance happens online, how much we're dependent on kind of like giving our data to these large companies. And this is, again, developers taking a crack at it by putting users back in control. That you don't, like, for example, there are some applications, Pravika is one of them. They're literally working on, removing Google from your life, right? Like you don't have to use any Google service. They have a full, chat plus email plus video calls replacement where you're never touching any centralized company at all. And you're in control of your software and who you're talking to and so on, right? So that's like disrupting the big tech monopolies, right? And interestingly, like both of these tracks actually use the same technology underneath, right? Which I've been in the computing industry for decades, but I've never seen a technology that is at the same time disrupting Wall Street and disrupting kind of like the current monopolies in Silicon Valley at the same time.
Yeah, that's something unique, and I haven't seen that. And what has got me into this is there's a lot of aspects to this: economics, the society part of it, the politics, the technology, the application space where you can build a lot of new things. You mentioned Pravika, so Pravika is just for my listeners. Pravika is an app built on Blockstack, private messaging app, and I feel like something like that India definitely needs. Most recently, I don't know if you're aware, there was a big incident around all these Bollywood actors. Their chats getting leaked and their personal lives on the front pages. It was as a result of death of one actor. And so it was like a total violation of their privacy, and it was out in public and all the news channels and media discussing about who's buying what drugs are they using, what they're doing. So, at that moment, it struck me like privacy is really important, especially in growing country like India and other developing nations who are not, I would say, as much privacy aware as the West. And so building applications on a network that respects your privacy, and something like a Pravika app would be a perfect fit for what's happening.
Yep. And I think I almost think of these things as kind of like disasters that are just waiting to happen, right? Like they're like ticking time bombs, like all of this data that is sitting with these pretty insecure databases that hackers can crack and whatnot, but they're also like almost like honeypots of data, right? Like a single source has data on like millions of users, so it's actually very economical for somebody to try and like hack that pot. Versus if in real life, someone needs to break into your home to take your belongings from your room, right? And they would have to do that a million times over to be able to steal things from a million people, right? And I think that's the model that's broken here, where in a decentralized way, you were talking about actors and their personal lives, kind of like information getting leaked. If they were using decentralized technology, it would be harder because it's just an upgraded encryption and all of those security focus helps. But let's say still obviously it's possible to hack somebody because you can hack someone's private key or somehow bug them and get access to their private key and whatnot. But if you do, you compromise one person, right? And it's a lot of effort to then go and attack the next person in different circumstances. And it's a little bit like trying to rob a house and then the next house and then the next house, right? So it doesn't scale. And I think that's the thing people need to understand, that we need to move to a model where the amount of work these hackers need to do is actually a lot more, and the rewards are, might not be worth it.
People in India have this notion of like, hey, privacy doesn't matter. I don't care if I give all my contacts to like a XYZ company, what I'm getting in return. But over the course of time with this, as you said, the incidents waiting to happen, this is one incident, and, we can see many more, in the coming years. So I guess people need to be more aware of it. The developer community should rise to the occasion, build applications. And also there is an incentive also, right, for developers. When you can have thousands of new founders, why have like just, top 2-3 companies build stuff?
That makes sense. I think what's unique about crypto is in some ways it actually solves the problem of building open source protocols and open source software by having these very clear financial incentives in place, right? So Bitcoin, you can clearly see why people would maintain the Bitcoin software, because it's powering a $350 billion network, right? Right. And same with the work that we're doing with the Stacks blockchain and with all the different tooling around it. Everyone is almost like a financial stakeholder, including my company. Like my company has a treasury of Stacks. We have done these offerings where people effectively came in and purchased the Stack's cryptocurrency for using it on the network or for locking it up and participating in consensus and so on. But all the different community members, there's something very unique here where it's a little bit like, if the first 100,000 users of Facebook actually owned a financial stake in the success of Facebook, right? Mm-hmm. So with this project, the early community members, the developers, everyone, like they really have an opportunity to have a financial upside. And that actually helps a lot because I think getting the incentive structure right in open source development actually goes a long, long way. And this is a very unique thing about crypto protocols. So,
do you have any future plans to, be listed on local exchanges in India also? Say WazirX and others?
Yeah. So I think in general, like the way our ecosystem evolves is like my entity, especially post Stacks 2.0 mainnet, basically builds developer tools. But there are other entities in the ecosystem like the Stacks Foundation or entities in Asia that are good potential people to talk to in terms of exchanges, listings, and so on. But I believe like Coin DCX is a India-based exchange, and it already lists some STX pairs.
Thank you. Thanks for your time, Muneeb. And if you want to know more about the project, developers out there, where they can go and get more information.
Yeah, so I think I'm fairly active on Twitter. I am at Muneeb. My first name Muneeb, and Blockstack is at Blockstack. You can go to blockstack.org, especially the community pages, to find out links to literally everything. Right, like there are local Telegram chapters and groups, and same that a lot of developers actually hang out on our Discord, and you can find most of those links if you go to blockstack.org and follow the community pages there. Thank you so much for hosting. This was fun.
Thank you. Same here. Thank you.
Bye. All right. Take care. Bye.
What cryptocurrencies are good at is money. They are a database of money, and they're good at that. And they're not so good at lots of other things.
You just heard the voice of Bram Cohen, creator of BitTorrent. Join me alongside my co-host Matt for our upcoming episode where we try to navigate the mind of this rare mythical creature as he talks about his new crypto project. If you have never heard of BitTorrent, please unsubscribe now. Just kidding. Please do subscribe to get updates on new episodes.